At 2:31 in the morning, a milk tanker pulls into the receiving dock at a Kraft Heinz cheese manufacturing facility in Wisconsin. The tanker carries 6,400 gallons. It collected from 7 dairy farms on a route that began at 9:30. The tanker carries 6,400 gallons. It collected from 7 dairy farms on a route that began at 9:30 the previous evening, moving through the dark across the rolling dairy country of south-central Wisconsin, stopping at each farm's bulk tank, pulling milk through the transfer hose, and moving on. The last farm on the route is 23 miles from this plant. The milk from the first farm on the route has been in the tanker's insulated stainless steel tank for 5 hours. The receiving technician takes the tanker's sample, a composite pulled from the load during transfer, and runs the antibiotic residue test before a single valve opens. Every load, every time, the test result comes back in 4 minutes. Negative. The receiving valve opens, 6,400 gallons begin moving into the plant's pasteurization system. By 3:15, 2 more tankers are staged at the dock. Kraft Heinz operates multiple cheese manufacturing facilities across Wisconsin, collectively processing over 2 million pounds of milk daily, approximately 233,000 gallons, into natural cheese, processed cheese, and cheese-based ingredients that reach retail and food service customers across the country. The Wisconsin plants that produce this volume draw from hundreds of dairy farms across the state's dairy production belt, are coordinated through tanker routes optimized to balance pickup frequency, farm production volume, and the 48-hour quality window that keeps bulk tank milk within specification from cow to processing vat. Wisconsin, the state that produces more cheese than any other in the United States. The state whose dairy identity runs so deep that the license plates say it, America's Dairyland. Kraft Heinz processes 2 million pounds of that milk every day. Wisconsin's dairy industry concentration in the south-central and western parts of the state, the same rolling, glacially formed landscape where European immigrant dairy farmers settled in the 19th century, created the geographic foundation that Kraft's early Wisconsin operations built on when James Lewis Kraft began buying Wisconsin cheddar in the early 20th century for his Chicago door-to-door cheese business. The Kraft brand that emerged from those early wholesale purchases grew into the most recognizable cheese brand in the United States through decades of retail marketing, product innovation, and the manufacturing scale that converting hundreds of millions of pounds of Wisconsin milk annually into consistent branded cheese products requires. The processed cheese product that Kraft pioneered, pasteurized processed cheese that melted uniformly, resisted separation, and extended shelf life far beyond natural cheese, required a manufacturing process that converted natural cheese into a product with characteristics the natural form couldn't provide. That process, patented by James Kraft in 1916, defined the company's manufacturing identity for a century. Kraft Heinz's Wisconsin facilities today produce across both product categories: natural cheese programs for the specialty and commodity natural cheese markets, and the processed cheese operations that remain central to the company's consumer brand portfolio. The milk that arrives at 2:31 in the morning may become cheddar aging in a humidity-controlled room for 9 months, Or it may become American singles through a manufacturing process that takes finished cheddar or similar natural cheese and converts it into processed product within hours. The supply network that delivers 2 million pounds of milk daily to multiple Wisconsin facilities operates through the tanker route logistics that the dairy industry has refined across a century of bulk milk collection. A Wisconsin dairy farm that milks twice daily, 5 a.m. and 5 p.m., fills its bulk tank continuously between milkings. The tanker arrives once every 48 hours for most farms, though high-producing operations with limited tank capacity require daily pickup. The coordination of pickup frequency, tanker capacity, route sequencing, and plant receiving schedules is a logistics optimization that runs continuously because the milk never stops. Antibiotic residue testing at every tanker load is the critical food safety gate that protects the commingled milk in Kraft Heinz's processing vats. A single farm shipping milk from a cow under antibiotic treatment whose withdrawal period has not cleared contaminates the entire tanker and potentially the batch of milk in the receiving vat if the load enters before the contamination is detected. Financial liability for the entire contaminated load falls on the farm of origin. The 4-minute test at the receiving dock is the barrier between the farm supply chain and the processing system. The large-scale cheese vats at Kraft Heinz's Wisconsin facilities, systems with working volumes of 10,000 gallons or more per vat, convert pasteurized, standardized milk into natural cheese through the biological and biochemical sequence that cheese-making has followed for millennia, executed at an industrial scale that a medieval cheesemaker would not recognize. Pasteurized milk at 72 to 73 degrees Fahrenheit, the vat temperature that starter culture activity requires, receives the lactic acid bacteria starter culture addition that initiates the acidification that cheese-making depends on. The starter culture converts lactose to lactic acid, dropping the milk's pH from approximately 6.6 toward the coagulation target of 6.4 to 6.5 for cheddar. This acidification takes 30 to 60 minutes under controlled temperature conditions that the vat's heating system maintains precisely. Rennet addition at the acidification target triggers rapid coagulation. The enzymatic action of chymosin in the rennet cleaves the kappa casein that stabilizes the milk's protein micelles in suspension, allowing the calcium-bridged casein network to form the continuous gel that fills the vat within 30 to 40 minutes of addition. The gel, smooth, firm, shall uniformly set across the vat's full 10,000-gallon volume, must cut cleanly without shattering into particles too small for the yield the process requires. Automated cutting harps descend through the set gel in 2 perpendicular passes, converting the continuous gel into uniform cubes whose size determines the final cheese moisture content. Smaller cubes expose more surface area to the subsequent heating and stirring, cook and stir, that drives whey from the curd through syneresis. A cheddar specification requiring 37% moisture in the finished cheese demands a cut size and cook and stir temperature that produces that moisture consistently across every vat. The cook and stir phase raises vat temperature gradually from 72 to 102 degrees Fahrenheit over 30 to 45 minutes, while stirring agitators keep the curd particles in suspension. Rising temperature causes the curd's protein matrix to contract, are expelling whey through the cut surfaces at the rate that the temperature curve and stirring speed control. A cheddar vat with 10,000 gallons of standardized milk entering will yield approximately 1,000 to 1,100 pounds of finished cheese, 10 to 11 pounds of milk per pound of cheese, with the remaining weight leaving as liquid whey. The whey that drains from Kraft Heinz's Wisconsin vats, the liquid fraction after curd consolidation, is not a waste stream. At 2 million pounds of milk daily, the whey volume represents a secondary production input that moves to whey processing, evaporation, spray drying, or ultrafiltration, producing whey powder, whey protein concentrate, and lactose that the food ingredient market consumes. The economics of large-scale cheese manufacturing include the whey revenue that converts what would otherwise be a disposal cost into a secondary product stream. The cheddaring and milling sequence that follows cook and stir at Kraft Heinz's Wisconsin cheddar operations converts drained curd mats into the fibrous knit texture that distinguishes cheddar from other cheese styles. After whey drainage, the curd consolidates into mats on the draining table. The cheddaring process involves stacking and turning these mats, initially 4 to 6 inches thick, at intervals over 90 minutes to 2 hours, allowing the weight of the stacked curd and the continuing acidity development from the lactic acid bacteria to work the curd's protein structure into the parallel fibrous strands that give cheddar its characteristic body. Automated cheddaring systems at Kraft Heinz's Wisconsin plants handle the mat stacking and turning mechanically at the throughput that 10,000-gallon vat output requires. The milling step that follows cheddaring passes the consolidated curd mat through a mill that cuts it into uniform, finger-sized pieces, standardizing particle size for even salting and consistent moisture distribution in the pressed block. The milled curd's temperature, pH, and moisture at this point must fall within the specification that controls final cheese quality. A milled curd that has dropped below the target pH range, too much acid development during extended cheddaring, will produce a crumbly, short-textured cheese. A curd still above the target, insufficient acid development, will produce a cheese that knits poorly and develops off flavors during aging. Salting the milled curd, sodium chloride at 1.7 to 2.0% of the finished cheese weight applied directly to the milled pieces serves multiple functions simultaneously: flavor or moisture control through osmotic pressure and the inhibition of undesirable bacterial growth during the aging period that follows pressing. At Kraft Heinz's Wisconsin scale, the salt application must distribute evenly across the milled curd volume. A mechanical salting system that meters precise salt quantities into each batch ensures the consistency that a manual salt spreading operation cannot achieve at this throughput. The pressed blocks, typically 40-pound daisy blocks or 640-pound barrel formats for commodity cheddar production, form in mechanical presses that apply progressive pressure over 6 to 24 hours, consolidating the salted curd into the block form that aging and further processing require. The aging facilities at Kraft Heinz's Wisconsin operations hold the natural cheese inventory that converts freshly pressed blocks into the flavor profiles that the retail and food service specifications the company supplies to require. Cheddar aging proceeds through a biochemical sequence proteolysis, lipolysis, and the flavor compound development that lactic acid bacteria and the milk's native enzyme systems drive, at rates determined primarily by temperature. A cheddar aged at 35 to 40 degrees Fahrenheit develops mild cheddar flavor profile in 60 to 90 days, medium cheddar at 4 to 6 months, sharp cheddar at 9 to 12 months, and extra sharp at 18 months or beyond. The aging room temperature controls the clock that time and room alone doesn't fully describe. At 2 million pounds of milk daily, with approximately 10% converting to cheese yield, at Kraft Heinz's Wisconsin facilities produce roughly 200,000 pounds of natural cheese per day across the multiple facilities. An aging room holding 9 months' worth of sharp cheddar production at that daily output rate holds approximately 54 million pounds of cheese. A physical inventory of significant capital value sitting in climate-controlled rooms, while the biochemical transformation that justifies the aging investment proceeds at the temperature the room maintains. The humidity control in Kraft Heinz's aging rooms prevents the rind formation and moisture loss that uncontrolled ambient aging would produce on an unwrapped cheese surface. Vacuum-sealed or film-wrapped aging blocks age in a controlled moisture environment that prevents the surface drying, that wastes yield, and produces texture defects in the exposed layer. The temperature and humidity monitoring systems that operate continuously in these rooms generate the environmental data that quality control tracks as the aging inventory's condition record. The processed cheese manufacturing that represents another major production stream at Kraft Heinz's Wisconsin operations converts natural cheese, often the plant's own aged cheddar, into the pasteurized processed cheese products that American retail consumers recognize in the Kraft brand. The processed cheese manufacturing sequence begins with natural cheese that is ground or shredded and combined with emulsifying salts, primarily sodium phosphates and sodium citrate, that perform the critical function of destabilizing the calcium bridges in the natural cheese's protein network and replacing them with emulsifier-mediated structures that allow the fat and protein to remain uniformly distributed during the heat processing that follows. Without emulsifying salts, heated natural cheese separates into a stringy protein mass and an oily fat pool, the familiar greasy melt that occurs when natural cheese overheats. With emulsifying salts at the right concentration and the right cook temperature, typically 160 to 180 degrees Fahrenheit, the processed cheese develops the smooth, uniform melt and the stable structure that allows it to solidify upon cooling into the consistent, sliceable product that American singles and block processed cheese deliver. The cook temperature of 160 degrees Fahrenheit reached and held for the required time constitutes the pasteurization step that gives pasteurized processed cheese its extended refrigerated shelf life. The finished product's water activity, pH, and the thermal processing it received collectively produce a food safety profile that allows refrigerated shelf life measured in months rather than the weeks that natural cheese delivers. At 2 million pounds of milk daily, with natural and processed cheese production running simultaneously across multiple Wisconsin facilities, the logistical coordination that moves milk from farm tanker to pasteurization to vat to aging room to processed cheese cooker to packaging and national distribution runs without interruption. 2 million pounds of milk per day, multiple facilities, hundreds of farms, continuous operation. The Wisconsin cheese system that Kraft Heinz operates traces its origins to James Kraft's early 20th century cheese business and to the Wisconsin dairy landscape that made it possible. The same rolling farmland, the same breed of Holstein cows, the same rural agricultural communities that have been producing milk for cheese for 5 generations. What changed is the scale, the automation, the precision of the biological control that large-scale vat systems require, and the processed cheese manufacturing innovation that extended Kraft's product range far beyond the natural block cheddar where it began. At 2:31 in the morning, the receiving valve opened and 6,400 gallons began moving toward the pasteurizer. By tomorrow morning's first shift, portions of that milk will be in press. Portions will be in the aging room beginning their 9-month wait. And portions will have already moved through the processed cheese cooker and into the packaging line. The tanker that delivered it is already back on the county road, heading toward the next farm on the route. Wisconsin's milk never stops moving. If this look at the tanker logistics, large-scale vat cheese making, automated cheddaring and milling systems, aging room operations, and processed cheese manufacturing behind Kraft Heinz's 2 million pounds daily Wisconsin cheese system gave you a clearer picture of what turns a Wisconsin dairy farm's milk into the cheese on American grocery shelves. Hit the like button and help the algorithm reach more viewers who want this level of detail. Subscribe for more deep dives into the processing systems and supply chains behind everyday food brands. Drop a comment and tell us where you're watching from. And tell us if you're watching from Wisconsin, because this one is yours.